Hi guys, this is Mrs. Allison. So today we're going to continue the idea of multiplying, but this time we're going to switch to the idea of multiplying polynomials. So yesterday we did a monomial, a single term, by a polynomial. Sometimes it was a binomial, 2 terms in the parentheses. Sometimes it was 3 terms in the parentheses, but today we're going to look at what happens when we multiply 2 polynomials. So it may be 2 binomials, it may be a binomial times a trinomial, lots of different options here, but we're going to look at 2 techniques, and I'm going to let you choose which technique makes the most sense for you. But we're going to start with what we call the FOIL method. All right, the FOIL method. If I were to talk about the FOIL method, I would say that this method really is only useful for a binomial multiplied by another binomial. So this method works best for a binomial multiplied by another binomial. Now, we can use it for other things, but the acronym of FOIL doesn't really hold up when we get to bigger terms than binomials. So remember, what's a binomial again? 2 terms. So here is the order in which we use the FOIL method. The FOIL method, the F, stands for the firsts. The O in the FOIL method stands for the outsides or the outers, and it kind of just depends on which way you call it. It doesn't really matter, outsides or outers. The I of FOIL, well, if O stands for outsides or outers, the I stands for insides or the inners. And then the L, well, if F stands for firsts, then the L stands for lasts. Okay, first, outside, inside, last is how we would read that FOIL. And this is just a technique, a way to help you remember what we need to multiply each term by. Okay, so let's talk about our firsts. When we talk about the firsts, what we're referencing are the first 2 terms in each parenthesis. So in our first example, the 2x and the 4x would be referenced as our firsts. Okay, so I'm just going to put a little F here and an F here to represent those 2 terms are our first. They're the first in each of the parentheses. And what I'm going to do is I'm going to take and multiply the 2x by the 4x. Okay, 2x times 4x. Well, what is 2x times 4x? We get 8x squared. Okay, so we did the firsts. So that's my first step. Now what I'm going to do is I'm going to multiply my outers or my outsides. Well, my outers or my outsides are the ones that are on the outmost part of the parenthesis. So the 2x and the 1, those are my outers. So I'm going to multiply the 2x and the 1. Let's go back. So if these 2 are my first, my outers are the 2x and the 1. So I'm going to multiply a positive 2x times 1. Then my insides. Well, my insides are the inner 2 ones inside of the parentheses. They're the ones squished together. Okay, so those 2 squished together, this 3, this 4x are my inners. So we would do 3 times 4x. And then my last 2 are the last 2 in each of the parentheses. So where my first are the first 2 in the parentheses, my last are the last 2 in the parentheses. So I would get 3 times 1. I didn't go in the same order. So 2x times 1 is 2x. 3 times 4x is 12x. 3 times 1 is 3. Now, these all happen to be positive, so all of these signs in the middle will be positive. And now my job is to look and see if I happen to have any like terms. Sometimes we get like terms with this, and sometimes we do not. So I'm going to look for any like terms, and I'm going to combine what like terms I have. And I can see here that I have a positive 2x and a positive 12x. Those are my like terms. So I end up with 8x squared plus 14x, because 2x plus 12x is 14x, plus 3. So this is what it looks like to use the FOIL method. And when I multiply a binomial by a binomial, in this case I got a trinomial, 3 terms, because my middle 2 terms added together. They were like terms. So let's look at one that maybe has a negative sign in it. All right, the first thing I would like you to do is think about what your firsts are, your outsides are, your insides are, and your lasts are for this problem. All right, hopefully you had a chance to think that my first, let's go back to a pen. My first would be y and 2y. So my first, I'm going to multiply y times 2y, which gives me 2y squared. My outsides are y and negative 7. That negative 7 is important. So y times negative 7 gives me negative 7y. My insides, my innermost two are the negative 1 and the 2y. So I've got negative 1 times 2y multiplied together gives me negative 2y. And my lasts, I have a negative 1 times a negative 7. We have to take those signs with us. And when I multiply those, I get positive 7. So you'll see here my signs are a little bit different than they were on the last one. I have some negative signs I need to deal with. But I also need to deal with like terms, and I have a negative 7y and a negative 2y. So combining these like terms, I'm going to get 2y squared minus 9y plus 7. So in standard form, from highest exponent to lowest exponent, in alphabetical order, I get this trinomial of 2y squared minus 9y plus 7. So what I would like you to do is hit pause and try the next 2 examples. I know you could just listen through, but I'm asking you to pause and try it because this is how you're going to get better. Okay, let's look at this one. My firsts, I have an x times an x squared. X times x squared gives me x cubed. My outsides, I have an x times a 6, which gives me 6x. My insides, I have a 4 times an x squared, which is 4x squared. And then my lasts are 4 times 6, which is 24. Now, in this particular problem, I happen to have no like terms. But what I notice is this is not written in standard order or standard form. In order to be in standard form, I need to rewrite this as x cubed plus 4x squared plus 6x plus 24. So now I've FOILed it, I've multiplied it, and it's written in standard form. All right, let's look at the very last one. Firsts. Hopefully you had a chance to try this. Okay, let's say you didn't do example 3 right, although you tried it. If you feel like you now have the hang of it, hit pause again, and let's try example 4. And then come back and hit play. So, the firsts. I did that before. The first, 3a times 2a, which gives me 6a squared. My outsides, I have 3a times 3, which is 9a. My insides, I have negative 1 times 2a, which is negative 2a. And my lasts, I have negative 1 times 3, which is negative 3. On this one, I do have like terms. This is a positive, so I have a positive 9a and a negative 2a. So that gives me 6a squared plus, I have 2 like terms, plus 7a minus 3. And there we go. That is the process of FOILing. We're going to look at another idea that allows us to multiply polynomials. And we're going to call this one the box method for lack of a better term. This will actually help us when we go to factor. But what I like about the box method is or can be used for any multiplying, for all polynomial multiplying. But what I really like about it, what I really like about it, and this should come as no shock to you, I like that it's really organized. It allows me to keep things very, very organized so that I make sure I have all of my terms. I didn't miss any doing the foiling. I didn't forget the O or the I. I didn't forget anything because this box method organizes it very well. It also helps when I've got bigger polynomials. So I'm going to show you my first example, and then I'm going to have you try it. All right, for the first one, the first thing I'm going to do is I'm going to take my first polynomial. In my case, my first polynomial happens to be this 2x plus 3. And I am going to write a positive 2x outside the first box and a positive 3. So that when I look at this vertically, I see a 2x plus 3. The same thing I see right here. Now I could write a plus 3, but I'm not going to do that. This positive 3 says the same thing. And then I'm going to take my other polynomial, in this case it's a binomial again, which is 4x plus 1, and I'm going to write a 4x on top and a 1 on top, a positive 1. So again, this term right here reads 4x plus 1. And if you want to, you can write that plus in there for that positive 1 and the positive 3, but you don't need to. All right, now let's look. What I'm going to do now is I am going to take and I'm going to multiply so that inside each box, the answer that's inside each box is the result of the multiplication of the two terms that intersect that box. So for example, on this one, I have a 2x and a 4x. So I'm going to multiply 2x times 4x, and 2x times 4x gives me 8x squared. So that's what's going to go in the box, is the 8x squared. My next box that I have, I'm going to multiply the 2x and the 1. So 2x times positive 1, which gives me positive 2x. Then I'm going to repeat that. Positive 3 times positive 4x. So 3 times 4x gives me 12x. That goes in my next box. And finally, I'm going to multiply the 3 times the 1. And the 3 times the 1 goes in my final box, which is just 3. Now what I have are a bunch of terms where I can look for like terms in my problem. And looking for like terms in my problem, I see that I have a like term of a 2x and a 12x. So I'm going to combine those two like terms. I'm going to do whatever the signs tell me. Those are both positive. So positive 2x, positive 12x, and that's going to give me 14x. So I'm going to write in standard form 8x squared plus 14x, and again, this 14x came from the sum of those two like terms, plus 3. So my answer is 8x squared plus 14x plus 3. Hey, look at this. We did this problem. That was our very first foiling problem. And if you'll notice, some of the same multiplication happens. Like we still multiply the 2x times the 4x. It just looks different down here on the box method. We still multiply 2x times 1. It's just organized differently. So we have the same result whether I use the FOIL method or the box method. So what I would like you to do is hit pause and try example 6. Try example 6 on the box method. Okay, now it doesn't really matter. I know on the first problem, I put this first parenthesis on this side. It doesn't actually matter which side of the box you put it on. So it doesn't really matter, but I'm going to go ahead and do the same thing. So this is an M, and a negative 5. Notice I'm keeping the sign. And this is a 3m and a positive 11. 3m and a positive 11. And now I'm going to go through and do my multiplication. M times 3m gives me 3m squared. M times 11 gives me 11m. Negative 5 times 3m gives me negative 15m. Ran out of room on that box. And negative 5 times 11 is negative 55. And again, if I were just doing this on my own, I probably wouldn't show the steps of what I'm multiplying. I would leave those gray letters off, but if for my sake, for right now, it helps me organize it just a little bit. I notice that I have a negative 15m and a positive 11m. So combining my like terms, 3m squared, this would be minus 4m because negative 15m and 11m. And then minus 55. And there's my answer. How do you do? Okay, let's try it when it's a little bit bigger. Now I set this box up a very specific way for this problem. So it's very clear as to which numbers I should write where. I see I forgot a parenthesis. All right, I'm going to write my x and my positive 4 on the left-hand side. Across the top, I'm going to write x squared, 6x, and 1. And I'm going to do the exact same thing I kept doing before, where I start to multiply the terms. So x times x squared, again, I'm going to write them for now. I won't do this after today. So this gives me x cubed. I have x times 6x, which gives me 6x squared. I have x times 1, which gives me just x, or 1x. It doesn't really matter how you write it. 1x or x is fine. I have a 4 times the x squared, which gives me 4x squared. I have a 4 times a 6x, and 4 times 6x is 24x. And then finally, I have 4 times 1, which gives me 4. Notice when I write this in this box method, it keeps everything very, very organized. And I can start to see my like terms. Notice I have a 6x squared and a 4x squared. But notice also I have a 24x and a 1x. So I'm going to make sure I combine my like terms. I have no other x cubed, but I do have a 6x and a 4x squared. So that gives me 10x squared. That's the like terms from the green. Plus, I have a 24x and a 1x. We'll call that 25x. And then I have a 4, positive 4. So I get x cubed plus 10x squared plus 25x plus 4. All right, now I want you to hit pause and try the next one on your own. See if you can get that binomial times a trinomial. See what you get for a result. All right, hopefully you've come back. And if we're going to plug this in, 2v and 3, 4v squared, negative 3v, and negative 6. And now I'm going to do my multiplying. So 2v times 4v squared gives me 8v cubed. 2v times negative 3v gives me negative 6v squared. 2v times negative 6 gives me negative 12v. 3 times 4v squared gives me 12v squared. 3 times negative 3v equals negative 9v. And then 3 times negative 6 gives me negative 18. And now I'm going to see if I have any like terms. Well, I happen to have a negative 6v squared and a positive 12v squared. I also happen to have a negative 9v and a negative 12v. So now I'm going to combine like terms. 8v cubed doesn't have any like terms. 12v squared minus 6v is 6v squared. Negative 9v minus 12v, I end up with negative 21v. And then finally a negative 18 that doesn't have like terms. So my like terms were the 6v squared and the negative 21v when I combine them. And so my final answer for this multiplication is 8v cubed plus 6v squared minus 21v minus 18. All right. Now, I want to talk about one of the most commonly missed problems. It would be wise of you to put a star by this problem, this example 9, because of the way it's written. So I'm going to scroll up. This example 9 would be wise of you to put a star by. Here's why. When I look at this problem, what does it mean to be squared? Remember, when we square something, this simply tells me that I am doing p minus 7 times p minus 7. So I am multiplying a binomial times a binomial. I cannot distribute in to addition or subtraction. Let's make a note of this. Cannot distribute an exponent into addition or subtraction. So let me give you an example. If I have negative 7p squared, that's multiplication. I can distribute that in because I am doing negative 7 squared and p squared. Or I could think of this as negative 7p times negative 7p. In both situations, I get positive 49p squared. I can do that. What I cannot do is if I am taking in p minus 7 squared, I am not going to be able just to distribute that in. This is equivalent, or should be equivalent to, p minus 7 times p minus 7. Let me prove to you that this is not the same as distributing. So what I want you to do is hit pause and try number 9 and tell me what polynomial we get when we do p minus 7 squared. Pick whatever method you would like. All right, I'm going to choose foiling because that's how it's written. Actually, I'll show you both. If I do foiling, my firsts are p times p, or p squared. My outers are p times negative 7, or negative 7p. My inners are negative 7 times p, negative 7p. And my lasts are negative 7 times negative 7, which is positive 49. When I combine like terms, I get p squared minus 14p plus 49. Now let's look at it if we had used the box. If we had used the box, I would have a p and negative 7 down the left-hand side and a p and negative 7 across the top. P times p is p squared. P times negative 7 is negative 7p. Again, negative 7p. And then positive 49. And my like terms that I'm going to combine, in this case, my like terms are the negative 7p and the negative 7p. And the end result is p squared minus 14p plus 49. Okay, so we know we get this trinomial of p squared minus 14p plus 49. I want you to think for just a second. If we go back over here, if I had tried to distribute, just watch, please do not write. If I had tried to distribute, we'd end up with p squared minus 7 squared. I'd get p squared plus 49. Great, I have part of my trinomial, but I'm missing this inner part. We're missing the outside and the inside, the oi. So this does not work to distribute the power through. I have to multiply the term by itself. Okay? So watch for that if you have that funky type of problem. All right, here's what I want from you. If you didn't fully understand this, please do not go on to the homework just yet. Go back and watch some of this. Maybe now that you've written down everything, put your pencil down and just watch the video again. See if it starts to make more sense so that then you can go and practice your worksheet. All right, so that is it on multiplying polynomials for right now. Hopefully one of those two methods makes sense, and we will talk to you soon.